Okay, this tutorial starts out with chapter 5.1, and that's evaluating exponents or powers with rational exponents in them. And we have to recall a couple of things here. We have to remember that if you have the form of x to the power to the root of nth root of something, that would be the same as saying x to the power of 1 over n. Or if you look at it, you can also have, if you have a larger power of the x, say x to the power a to the nth root, that can be written in rational form as x to the power of a over n. Remember, the n value, the denominator, always comes from this power of root that's in the notch here. So here's a couple of practical examples. So if I had x to the 1/5, that would be the same as saying the fifth root of x. But if I had x to the 3/5, that would be the same as saying the fifth root of x cubed. So we're going to look at some examples that come from section 5.1 in this tutorial and evaluating these rational expressions. And I'm just going to start with a few examples. I'm going to move this up here a little bit. And let's say our first one here, examples. Say I have let's say I'm going to go with something simple. Say I have 256. Oh, pen's dying out here. Let me switch over here. Try this one. 256 to the power of 1/4. So that means the fourth root of 256. If we want to write it in another way, we can say that this would be the same as saying 256 to the fourth root. And, well, how do you reduce down from 256? Well, one way to do that is to use prime factoring method. So if we go here and we do the prime factors of 256, okay, so take 2 out of 256, and that would give us 120, or sorry, pardon me, 128, okay? So we can take 2 out of 128, and that would give us 64. 2 out of 64, that would give us 32. 2 out of 32 would give us 16. 2 out of 16 would give us 8. Or sorry, yeah, 8. And then 4. And then 4 is 2 times 2. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8 2's to get 256. So to take the fourth root of that, we just group them into pairs of, or groups of 4. So that would be the same as saying 2 times 2. So the fourth root of 256 should equal 4. And we can check that by multiplying. 4 times 4 is 16 times another 4, which would be 64, and then another 4 to get 256. So that's a simple example of just working out that problem. So let's go to another problem, B. Let's say you have something like, let's use a rational expression in our exponent form. So let's go with, let's say 8 to the power of 2/3. Now, if we're going to work this one out, we have to, there's a couple different ways you can do it, but we have to realize to ourselves that we have to think in terms of this format again. So we have to realize that we're going to be using this property here, and we can do that and convert it. So this would be the same as saying the cube root, because the 3 is on the bottom, of 8 squared. Okay, and we can simplify this now using our prime factors again. So we know that this would be the same as saying the cube root of 8 can be 3 2's, and there's one of the 8's, and since it's 8 times 8, 3 more 2's. So as we can see here, we're going to end up getting, if we want to do cube root 2 times 2. Take out a group of 3, that's 2. Take out a group of 3, that's another 2. So this is going to equal 4. So 8 to the power of 2/3 is 4. Okay. So far, so good. Let's flip my page here. Make sure that's still in our field of view. Okay, and let's look at some examples that would maybe have negatives in their value, and maybe fractions as well. So let's go with C here, being, let's say, 32 over 50, which I know we can reduce, but I'm just making one up here, to the power of 1/2. Okay, so there's a couple of different ways you can look at this as well, but we can think of it as saying, well, it's the square root completely of 32 over 50. Okay. So when you're working that one through, you're thinking to yourself, well, that's not two perfect square roots, so we have to do some simplifying there. So that would be the square root, and we don't necessarily need to put the 2 there, because when you don't see the 2 there, it means automatically square root. So that'd be like saying the square root of 32 over the square root of 50. Okay. Okay, this one doesn't work out evenly, but 32 is 2 times 2 times 2 times 2 times 2, which is 5 2's. And 50 is 2 times 2, which is, 2 times 5 times 5. It's 20. So as you can see, this is not going to work out completely, Bert, and that's still square root. So if we simplify these, take these 3, or these 2 and 2 out, so that would be 4, or 2 out, and there's still a root 2 underneath. Okay. This is our first example with a radical in it. You can take out a 5, and there's still a root 2 underneath. Okay? So we can see that these two root 2's here are going to cancel. One over the top, and it's just going to be 4 over 5. Okay? And that makes sense, because if we would have reduced down here, this would have been 16 over 25, and if we take the square root of 16 over 25, it's 4 over 5, which would have been one way that you could have simplified some of your work as well, but I just wanted to show you the method that involves some radical expressions as well. So in this tutorial, I'm going to do one more example. Here we need to do a few with negatives in them, so let's do that quickly. So let's say I have something like this. Oh, negative 27 to the power of, what do we work here for? Negative 2 over 3. Or let's not make that one negative, let's just say 2 over 3. Okay, so negative 27, that would be the same, saying the cube root of negative 27 squared. Okay, now we can take 27, negative 27, and square that if we like, or we can do prime factors of 27. So you know a negative times a negative is going to give you a positive under there, so that's going to be fine. And 27 is 3 times 3 times 3 times 3 times 3 times 3. So if we take out groups of 3, we get 3 times 3. So we know this is going to turn out to be 9. And that would be our examples for solving radical expressions. Our next tutorial will do some more examples from the next section.